Hey everyone, welcome back to another Calculus 1 video. This is the second part of the chain rule, section 3.7. We went through the concepts and the basic definition of the chain rule in your first part, and so this is just a bunch of examples. I'll work one, you guys try it, that kind of thing. And so let's take a look. Y prime, we're looking for y prime of the function 5x to the fourth plus 1 to the second. So what is the inside function? The inside function, we call that u sometimes. That's 5x to the fourth plus 1, which means y is just u squared. And so when we take the derivative of each of these, dy du is equal to 2u, and du dx is equal to 20x to the third plus 0. And so if we want to find y prime, we just want to multiply these together. Dy du times du dx. Remember, y prime is another way to write dy dx. And so y prime then is equal to 2u times 20x cubed. And of course, we don't want to leave it with a u in there. So we have 2 times 20, which is 40, times 5x to the fourth plus 1 times x cubed, and that's y prime. So again, I do expect you to simplify like constants, but other than that, we don't really have to worry too much, okay? So now I want you to try part number 2 here, but remember, the fifth root is the same thing as negative x cubed minus 4 raised to the 1/5 power. So take a minute and try to figure that out, and pause the video, and I'll come back and show you how to do it. Okay, so what's u? What's the inside function? The inside function is this stuff, negative x cubed minus 4, which means y is equal to u to the 1/5. So when we go to take derivatives, dy du, you bring down the 1/5, u to the negative 4/5, right? 1/5 minus 1 is negative 4/5. The du dx, that's equal to negative 3x squared minus 0. And so to find y prime, we simply multiply these two guys together, 1/5 u to the negative 4/5 times negative 3x squared, and then plug back in for u. So y prime is equal to 1/5 the group negative x cubed minus 4 to the negative 4/5 times negative 3x squared. And that's your final answer. And again, you don't have to simplify. And so that's perfectly good. Okay? Now, what happens when we need to put the chain rule in tandem with our other rules? Problem number 6 from the extra worksheet that you had is a group raised to the third power, but that group, my u, is a big old fraction, 5x to the 5th minus 3 all over negative 3x cubed plus 1. And so we have y equals u to the third, but u is this. What do we have to do here? We have to do a quotient rule here. So when we go to do the derivative of u, we're going to have a big old mess. And so let's try to do this a little bit more directly. We'll call this f prime of x this time as the derivative. And so what do? We bring down the 3, right? How do we find y prime? We bring down the 3 and square the power. But what happens to this stuff inside? Nothing happens to u. u stays the same. u stays the same. Remember, one step at a time, one rule at a time. So I just did the power rule, bring down the 3. So I can't do a quotient rule yet. I have to do the quotient rule way on the outside. So how do I do the quotient rule? The quotient rule is the bottom times the derivative of the top. 5x to the 5th, bring down the 5, 25x to the 4th, minus 0. Okay, that's a 4 there. Minus the top, 5x to the 5th minus 3, times the derivative of the bottom, bring down the 3, you get negative 9x squared plus 0. And then that's all over the bottom squared, negative 3x cubed plus 1 all squared. All of that stuff is your second part. So this part here is my dy du. This part here, all that is your du dx. So I'm trying to show you a couple different methods and different ways of thinking about it. A lot of people like the y and the u method. A lot of people like that, but in case you are struggling with that a little bit, you can think of it as kind of the derivative of the outside times the derivative of the inside. Just make sure you leave the stuff on the inside alone the first time through. Okay, one rule at a time. The 3 comes down to the 2, that's one rule, times the second rule, which in this case is a quotient. So here's another quotient. Again, this is x squared minus 3 fifth root, so that's a 1/5 power, and your denominator is negative x minus 5. So the question here is, when you go to find f prime, what's the inside function here? What's the big picture here? And you, just because we're doing the chain rule doesn't mean you always do the chain rule first, okay? So if you need to, take the fraction and think of it as a top and a bottom and see what happens. Pause the video, come back and check your answer. Okay, so I am going to think of this as a top and a bottom because the big picture this time is not the chain rule. Back here, this was stuff raised to the third power. It was a chain rule. This is not. This is a top and a bottom. So this is different. So where my derivative is supposed to be a quotient, I get what? bt prime minus tb prime over b squared. So now I'm going to take some time and figure out what those are supposed to be. So t of x is the top function, x squared minus 3 to the 1/5. How do I find t prime? Well, what's the big picture here? The big picture here is the big picture here is a chain rule. Power of 1/5, here's the inside function. So bring down the 1/5. X squared minus 3 stays the same. I subtract 1 from the power. And then I multiply by the derivative of the stuff inside, 2x minus 0. Okay? How about the bottom function? The bottom function is, of course, just minus x minus 5, and so the derivative of the bottom, b prime, is just negative 1 plus 0. So if we put these all together in this expression, we end up with b, which is negative x minus 5, times t prime, which is all this stuff, 1/5 and 2x, so I can make that 2/5 x, times x squared minus 3 to the negative 4/5. That's all of the derivative of the top, minus the top, x squared minus 3 to the 1/5 times the derivative of the bottom, which is negative 1, all over the bottom squared. Negative x minus 5, all squared. So this guy right here, this is my final answer. Sure, I could make that negative and that negative make a plus or whatever, but I don't have to simplify. This is it. This is good enough. But maybe not a bad idea to use my t prime and my b prime, again, as I'm getting used to all of these rules. You've got to keep things straight. You've got to do them in order, one rule at a time. Okay? So here's one more example for you. Y equals cosine to the 4th of x squared plus 1. I'm going to give you a hint. You do not want to leave it as cosine to the 4th. That is shorthand notation. And it's great notation, but it's not great when you're thinking about this as what's the big picture. And the big picture is I have stuff to the 4th power. Okay, so I have an inside function. This is my u, but wait a minute. If y is equal u to the 4th, what's u? U is equal to cosine of some stuff. Well, that means there's another inner function, x squared plus 1. This is a function inside of a function, so I need to call this like v, and then v is x squared plus 1. I have a chain rule. I have a double chain, and that's totally legal. So now if you want dy dx, what do you have to do? I need dy du, I need du dv, and I need dv dx. So let's see what we get. The derivative of y with respect to u is 4u cubed. The derivative of u with respect to v, what's the derivative of cosine? Negative sine of v. The derivative of v with respect to x, that's 2x plus 0. So now I can plug everybody back in, and I can get dy dx. I get 4u cubed times negative sine of v times 2x. Now I need to replace u and v, so u is cosine of v cubed, and then I have negative sine of v still. I'll do one replacement at a time, 2x. And so I get 4 cosine of x squared plus 1 times negative sine of x squared plus 1 times 2x. You could just leave it like that. If you wanted to combine constants, 2 and negative, you get negative 8 out front, negative 8x out front, cosine cubed of x squared plus 1 times sine of x squared plus 1. That would be a little bit simpler version of it, but I would be okay with this. Okay? So you always have to make sure you're going in the right order, and you go one step at a time. In this case, I was a function inside of a function inside of a function. I had 3. So I had to think of it in terms of that. Okay? So here's one that is not the same, right? This is a product of two things at first, but here you're looking at a chain rule because this is stuff to a 4th power. Here you've got e to a stuff. The derivative of e to the x is e to the x, but if you have e to some stuff, that is not the rule. That's a chain rule, right? So you got to think of it that way. So take a minute. I don't necessarily expect you to get this one, but try it. Take a couple minutes, pause the video, and then if you need it, I'll solve it for you when we get back. Okay, so this is your big F, this is your big S. These are your first and second functions. F of x is x cubed plus 2x to the 4th. What's the derivative of that? Well, I'm going to use a chain rule. Bring down the 4, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the stuff inside. That's your u, 3x squared plus 2. So f prime I'm pretty confident that you guys can get by now. S, however, is e to the 5x plus 1. So here y is e to the u power, and u is 5x plus 1. So when I go to take the derivative using the chain rule, I get e to the u for y, but then the derivative of u is an extra 5. And so the derivative s prime of x is the product of these two. It's e to the power, 5x plus 1, times the derivative of the power times 5 in this case. Okay, or 5e to the 5x plus 1. So now I have to put all this together with the product rule. The product rule, of course, for the derivative y prime is f prime s plus fs prime. So what is that going to look like here? We're going to have y prime equals f prime, which is 4x cubed plus 2x all to the 3rd times 3x squared plus 2. That's f prime times s, e to the 5x plus 1, plus, let's slide down here, and if you run out of room in your paper, you can do the same thing. Fs prime, f, is x cubed plus 2x all to the 4th times the derivative of s, which is 5, e to the 5x plus 1. And again, you don't have to simplify. This is perfectly legit, and that's your final answer. That's your derivative. Okay? So once again, as with many of these videos, I cannot possibly begin to do the number of examples that there are nuances with regards to how many different ways to do this. But you do need to be able to learn the basics of the chain rule first and then apply the basics of the chain rule to bigger and more complex scenarios, including bringing in product rule, quotient rule, stuff like that. Okay, so lots and lots of problems to practice. You're going to have lots of worksheets on D2L and lots of problems in my math lab to play around with. Okay, hope that helps. We'll see you later.